Welcome, fellow investors and friends of Delta Resources. This is Onaga Tessier, your president and CEO. We put out a press release this morning to update you about our geophysical results and interpretation at the Delta 2 property in Chibougamau, Quebec. So we thought we'd release the short video presentation at the same time to better convey why we're so excited about these results. The complete presentation is about 13 minutes, starting now. Before we get going, though, I invite you to read through our forward-looking statement to better put into context the statements I'll be making during this presentation. I also need to tell you that I'm a qualified person under the rules of National Instrument 43101. A quick reminder here, our Delta 2 project is located 35 kilometers southeast of the Chibougamau mining camp with easy access via paved Highway 167. It's a very large property, now covering over 146 square kilometers. I should say the Chibougamau mining district is responsible for the production of 1.6 billion pounds of copper and 3.2 million ounces of gold. But interestingly enough, the Delta area has seen very little in the way of modern exploration. I'll draw your attention to the Lemoine mine, a past producer of high-grade zinc, copper, and gold, located about 1.2 kilometers north of the Delta 2 project. The Lemoine deposit's important because it's a deposit type that we call volcanogenic massive sulfide. There are many deposits of this type in the world, and they almost invariably occur in clusters. But the Lemoine deposit sits all by itself. In the 70s, past explorers have looked for the other deposits in the area, but in vain. Our advantage is that we're looking for the cluster with state-of-the-art modern geophysical methods, and so far the results have been very encouraging. Here's a quick reminder of the geology of the property. This is a geology map of the area, and the different colors represent different types of rocks. Without getting too technical here, the important rock units consist of two cycles of volcanic rocks. The oldest cycle is shown here in the dark greens, and the youngest is shown in the pale green and yellows. The base of the sequence is intruded to the south by a synvolcanic intrusion that is similar in age and composition as the Chibougamau Pluton, which is responsible for all the copper-gold mineralization of the Chibougamau camp. Most important, let's look at the mineralization in the area. At the Delta 2, we have two types of mineralization. We have volcanogenic massive sulfide, VMS for short. The very rich Lemoine mine that produced over 750,000 tons grading 9.5% zinc, 4.2% copper, and 4.5 grams per ton gold. But we also have the gold-rich Delinel and Cartier prospects, which are gold only. Typically, VMS deposits have relatively small footprints, but they're very rich. And as discussed earlier, they occur in clusters on specific stratigraphic horizons. In the Delta 2 area, that stratigraphic horizon is shown here in the dashed white line, and it's located at the contact between the two volcanic cycles. We also believe the whole second volcanic cycle has great potential for polymetallic gold-rich deposits. The second type of mineralization are gold deposits related to the Pluton. The R14 deposit is an example on the property, but there's also the Chevrier gold deposit located just to the west of the Pluton with about 800,000 ounces of gold so far, and the past producing Geoman mine south of the Pluton, which produced over 1 million ounces of gold with some copper. We believe the southern portion of the property close to the Pluton holds great potential for this type of deposit. Now let's talk geophysics. This slide will show you what state-of-the-art modern geophysics can do for us. This initial map shows the total magnetic response on the Delta 2 property. These magnetic maps just reflect the amount of magnetic minerals in the rocks. Since different rocks have different amounts of magnetic minerals, we can see some contrasts. On these magnetic maps, the warm colors like the yellows, the reds, and the pinks indicate a relatively high amount of magnetic minerals, while the cooler colors, such as the greens and the blues, are less magnetic. The data from this map is available from the Quebec Ministry of Energy and natural resources. Now, on this map, we just overlaid the same total magnetic response, but with the high-resolution surveys that Delta is using to interpret the geology. The background is still from the Quebec Ministry. As you can see, using these high-resolution surveys is a game changer because there's so much more detail that appear. This is actually a result of 5 different surveys that are stitched together and leveled for easier visualization. The surveys cover an astounding 221 square kilometers. Just note to the south here, the no-fly zone where there are power lines and only the ministry's data is available. So on the next slide, we'll zoom in onto this area here to the south where we flew a high-resolution drone magnetic survey. This is the total magnetic map of the southern portion of the property where we believe there's excellent potential for magmatic hydrothermal gold deposits. The way we interpret these maps is by looking at the strength of the magnetic response, the trends of these responses, and where these trends are disrupted. These disruptions are shown in the pale blue dashed lines on the map below. As shown on our exploration model, we're looking for structures that were originally at high angle with the intrusive contact of the Ladouversière pluton. We've drawn the Ladouversière contact right here, separating the rocks from the pluton that are poorly magnetic from the rocks that are more magnetic to the north, the volcanic rocks. Note the zones where these high magnetic volcanic rocks are truncated here, here, and here. We believe these zones represent structures that formed when the pluton was emplaced. Note that almost all the gold occurrences are located within these zones. These targets for gold mineralization are newly interpreted by Delta and have seen very little in the way of exploration. A new model like that, it lends itself to new discoveries. Now, if we look to the northern part of the property, we believe the potential there is for volcanogenic massive sulfide deposits. Those deposits consist of massive to semi-massive copper, zinc, gold-bearing metallic minerals that are typically conductive, just like the Lemoine deposit we discussed earlier. So to detect these deposits, we use a different method called electromagnetic methods, such as VTEM, which is short for Versatile Time Domain Electromagnetic. The area in black is where we flew our VTEM surveys. Before we go any further with our interpretation, let me explain what electromagnetic maps typically look like. This is an electromagnetic map on the left side of the screen. The background of these maps shows the magnetic response of the rock, just like the maps we were looking at earlier. Warm colors are magnetic, and cooler colors are not as magnetic. Overlain on the maps are these dots. Each dot represents where a conductive rock was detected by the instrument as the helicopter flew over. The full dots represent a strong conductor, the circle with an X represents a weak conductor, and the half full a moderate conductor. When several dots are aligned, it just means the conductor extends on several flight lines. Here in white, I just overlaid what the flight lines would look like on a portion of the survey. At the Delta 2, those survey lines were spaced by 100 meters. For example, this conductor is at least 500 meters long and has a generally strong response, while this conductor is about 300 meters long and has a moderate intensity. It's very simplified, but that's how you can visualize it. The other aspect we want to discuss is the type of conductor we consider a target for VMS deposits. This is an example of a conductivity map with our dots, just as I explained earlier. From the geology and the conductivity, we can interpret 2 folded rock units. The one furthest to the north is highly conductive over at least 10 kilometers long. We call these formational conductors. Now, we know that with VMS deposits don't have that type of large footprint, so instead, we look for shorter conductors and isolated conductors, just like these conductors here. Those are anywhere between 200 meters and 1.5 kilometers long. And just to illustrate, that's where the deposits were actually located. This map is taken from a Manitoba prospect. The takeaway from this slide is that we're looking for conductors of short strike length, not these long formational conductors. At delta 2, we also like a high magnetic association because the Lemoine deposit has a moderate highly magnetic signature. And we like those horizons where VMS mineralizations are already reported. So let's get back to our electromagnetic map of conductors at the Delta 2 project. And let's zoom in on the south block right here. On this map, we have our conductors, the dots, over total high-resolution magnetic response map. These white dots with a plus sign in it represent historical drill holes, and the white dotted line here represents the horizon that's favorable for VMS deposits. The stars just represent gold prospects. What we see in this block is at least 6 new isolated and short conductors 250 meters to almost a kilometer in length that have never been drill tested. The conductors are all moderate to strong. At least 4 of them are associated with magnetic highs like we're looking for, and they're close to our favorable horizon. These are all prime targets for VMS deposits, and I hope you can appreciate why we're so excited about these results. Now, this is only a small part of the Delta 2 property. Let's look at the whole property and you'll see what fuels our enthusiasm. All right, this is the same map but showing the whole property. These are the 6 prime targets that we just looked at in the southern portion of the property. But let's look at the rest of the property now. We have a minimum of 26 conductors property-wide that are exceptional targets for gold-rich VMS mineralization. It's almost overwhelming. I sure hope you can appreciate the scale and the quality of these targets, so I'll just linger onto the slide a little bit and let you look at them. All right, enough staring. So in conclusion, the Delta 2 projects is favorable for both magmatic hydrothermal gold and polymetallic VMS deposits. VMS deposits, such as the Lemoine deposit, generally occur as clusters on stacked favorable horizons. Lemoine, however, is the only economic VMS deposit in the area. Where are the others? Delta is the first explorer looking in the area since the 70s, that's over 40 years ago, with state-of-the-art modern geophysical methods. The new geophysics at Delta 2 is a game changer, allowing for a new geological interpretation and detecting new targets. New synclinal structures have been interpreted, pointing to 3 new areas of high potential for gold deposits, and gold occurrences already exist in these areas. A minimum of 26 high-priority VTEM conductors have been identified with excellent potential for VMS mineralization similar to the Lemoine mine. Delta is planning to better define these targets through geophysical modeling and follow-up fieldwork starting June 1st, 2020. Which will lead to drilling in the near future. Well, thanks very much for listening to this presentation. I hope you're as excited as we are. If you have any questions, don't hesitate to contact us. Our contact information are right here in the lower left corner of this slide. Again, thanks very much for your interest in Delta Resources.